Hi, this video will discuss the procedure and computation of Fieldwork 6 in Fundamentals of Survey, which is differential leveling with turning points using the double rodding method. This surveying procedure is very similar to the previous fieldwork, which was differential surveying with turning points. The main difference with this fieldwork is that two turning points are used instead, hence the name of the double rodding method. This method is applied so that the accuracy of the procedure is increased, and when there are no distinct benchmarks available for inspection. The instruments that will be used in this fieldwork will be the same as with the previous fieldwork, which is a precise level, marking pins, and a leveling rod. Contrary to the name of the double rodding method, it does not mean that two leveling rods are needed for this fieldwork. The party must designate one chief of party, who will lead the full procedure. The one rodman responsible for the leveling rod, one instrument man tasked with the precise level and taking the measurements, and one recorder in charge of noting the measurements and observations. This fieldwork will be virtually explained by the use of Minecraft, so that the viewer can easily understand the procedure.
In the procedure of the fieldwork, the chief of party first designates benchmarks 1 and 2, which will have a distance of about 300 to 500 meters from each other, with significant differences in elevation. BM1's elevation has to be either known or given by the professor. The instrument man then sets up the precise level at a suitable distance away from BM1, while a rodman holds the leveling rod at BM1. The instrument man then takes the backside reading of beam 1 and is recorded into the surveying notes by the recorder. This BS can then be added to the known elevation of beam 1 to get the height of the instrument.
The rodman then moves along the route to BM1 and marks 2 points using the marking pins as TP1L and TP1H respectively. The distance of TP1L and TP1H should preferably be equidistant with the distance between BM1 and the level. TP1L and TP1H preferably should have considerable differences in elevation, while also being quite near each other. The instrument man then rotates the level towards TP1L and TP1H and reads the foresight of each. The elevation of TP1L and TP1H is then calculated by subtracting the Fs of TP1L and TP1H respectively.
Instrument man then relocates to another spot along the route past TP1 before taking the backside for both TP1L and TP1H. The BS reading for TP1L and TP1H is then added to the computed elevation for TP1L and TP1H, respectively, to solve for the height of the instrument. The resulting values should be very near to each other. This process is repeated by the surveyor for the rest of the turning points until BM2L and BM2H are reached. The resulting computed elevation for BM2L and BM2H should be very near to each other. After that, the mean of the computed elevation of BM2L and BM2H will be the resulting most probable elevation for BM2. Now that we have already gathered data, we can now move on to the computation.
Now, here is the procedure of the computations for Fieldwork 6. The height of the instrument is equal to the elevation of the point where the backside is being observed plus its elevation of the point itself. The elevation of the turning point is equal to the height of the instrument minus the foresight of the turning point being observed. The most probable elevation of benchmark 2 is the mean elevation of benchmark 2 between the computed values from the last turning points, low and high. And these points of procedure can be summarized in these formulas. Now here is the given data table. We are given benchmark 1 and the low and high of turning points 1, 2, 3, 4, and 5, as well as the low and high of benchmark 2. Now we are to find the missing values for the height of each instrument and their respective elevations. Now, to find the height of each instrument, we must take the first elevation plus the backside. So that'll be 50 plus 3.548 is equal to 53.548, which is the height of the instrument of benchmark 1. Now, we are to use this height of the instrument in order to find the respective low and high elevation of turning point 1. And we will do that by subtracting their respective foresight from the computed height of the instrument. So that would result in 50.358 for the low elevation and 50.598 for the high elevation. Now, using these two respective values, we will then find the low and high height of the instrument for turning point 1, again using the respective values in order to not skewer the data given. And this process is repeated all throughout. So that will be for turning point 1, 2, 3, 4, and 5. Same as here, the process is being repeated for turning point 1, 2, 3, 4, 5, and benchmark 2. Now again, the probable elevation of benchmark 2 would be its mean. So using the computed values, which is 49.757 and 50.072, we will use those values, add them together, and divide them by 2 in order to get 49.9145, which is the probable value of the elevation of benchmark 2. Now you can see here is the sketch that is used for the survey. This was situated in Minecraft, and as you can see, here are the locations of each instrument that was used for this survey. That is all. Thank you.